Hi everyone, welcome back to Game Maker Cast. It's Mickey, and in this video we are going to talk about a shader again, specifically a scanline or CRT shader. So let's roll the introduction and let's get right into it. In the demo project that I have running in front of me, I just have an object bouncing around the screen, and I have the debug FPS showing at the top, and you can see roughly I'm getting about 12 to 13,000 FPS. Now, I did a whole bunch of research on this, and I found that there were 4 different methods that we could do for a scanline or CRT shader. Now, they're not all going to be shaders, but let's go through the pros and cons of each one that I found. So the first one that I found I thought was pretty neat. We basically create a very small surface. It's a 1x3 pixel surface. And then what we do is we draw a pixel on that surface, and then we just draw that surface tiled across the entire room or across the entire camera. However, the downside to this particular method of doing this, as you can see, yeah, it totally works, but right now we're running at just under 60 frames per second. And that's really not something that you want in your game. So I wouldn't really recommend this. This is pretty neat. So I thought we would take it a step further and just load the sprite into memory instead of drawing it each time. So if we load up the dot one, you can see that I'm just drawing a tiled sprite all the way across my camera. And if we take a look at the sprite, it is the same thing. It is a 1x3, except this will be loaded into memory. So let's add this one to our game and see the difference. You can see that we've increased our frames per second. We're now running at about 500 frames per second on my machine. Now let's take it a step further and look at one more method before we get into the shader, and then we'll explain the pros and cons here. So let's close this and close everything that we have. And what I want to do is check out this CRT full. We're basically doing the exact same line, except we're only drawing one sprite. And this particular sprite happens to be the same width and height as my current room or viewport. So if I click on edit image and I go in, you can see that it's just a bunch of lines here. So let's actually add this one into our room. So we'll go into our room, let's get rid of this instance and then grab our full one and now run our game. Now you can see that we are currently running at about 9,000 to 10,000 FPS, and this is a huge improvement. Now, the only thing that this isn't going to cover is, let's say in our game, we changed the resolution or we changed the aspect ratio. Now that when I draw this particular sprite, what's going to happen is it's only going to cover the size of the sprite that it is. So that means that everything here on the right side, we're currently not covering, and this is where a shader would definitely come in handy. So to start off, let's take a look at the shader object. We want to make sure that we are not able to draw the application surface by default. We need to make sure that we have control of that, so we will disable the drawing event, and then we need to create a variable for our surface, and that's basically going to take a picture of the application surface. Now the next two, I'm grabbing a handle to these two specific variables, and we're going to use these in the shader itself. We have a surface width and a surface height. So this I would set to basically your viewport width and height or your room width and height. It's basically just going to transform our UVs into X and Y coordinates. Over to the post draw event, you can see this code is fairly similar. We're creating the surface based on the room width and height, and then we are copying the entire application surface into our new surface. Down here at the bottom, we are setting the shader to our shader CRT, which we will create in 1 second. Then we are assigning the surface get width and surface get height, which is basically, if you look at the top, the room width and the room height. And then we are finally going to draw the entire application surface, and that's what the draw surface function is. So let's go ahead and create this shader, and you're going to see how easy this can be done. So we're going to say create shader here, and we will name it shader CRT. So by default, we'll have a vertex shader, and then we have a fragment shader, and we're going to do all the code in the fragment shader itself. So the first thing I want to do is create those two variables for our surface width and surface height. I'm going to use a uniform float. You could use a vector too, but I'm just trying to keep things a little bit more simple. The next thing I want to do is, instead of assigning the frag color right away, we're going to change this and we're going to store that color just inside a variable called C. Now for this particular exercise, basically what I want to do is I want to traverse from the top to the bottom, checking out the coordinates on the Y position. And if that Y position can be divided by 2 and is an even number, then we're just going to discard that actual pixel, which will give us the skylines. We could take it a step further and we could change the color to something like off-white or even green or something if you want, and we'll check out how we can do this. So we need to write a simple if statement, and basically what we're going to be doing is say if something mod 2 is equal to 0, which will give us even. So that means that we have to use the mod command. Now the mod command is only going to work with whole numbers, so we're going to floor whatever we're going to pass in here. And what we're going to pass in here is going to be our texture coordinate. So we need to use that variable. And then we only really care about the Y position. Now this will give us a number between 0 and 1, and we need to transform that into a pixel coordinate, which will be in between 0 and 512. So to do this, all we have to do is we have to multiply it by the surface height. Then we can close our floor command, and we want to mod this entire variable by 2. And if this entire thing, mod 2, equals 0, then we know that we have an even number. And like I said, what I want to do in this case is I just want to completely discard that pixel. Now, the only thing left to do is make sure we now reset our GL frag color to our color itself, which is the C variable. Now I'm going to check on my room just to make sure I actually have the correct information in here, and I do have the CRT shader. Now remember that we did modify our room to 1024 by 512, so if I hit F5, our room's going to load up. And you can see that the shader automatically is covering our entire room. And we are getting roughly 9,000 FPS, so we aren't taking any frames per second hit, and we are covering the entire thing. So this means that no matter what we change our room to, everything is automatically going to be adjusted for us because we are using a shader that will be flexible with our game. Now, before I actually end this video, the one thing I did want to show you is if I close my room and I go to my code, instead of actually just discarding it, what I could say is I could set the RGB value to something like an off-white. So the RGB is going to be 3 vectors. So I could just use a vector 3, and I could say, let's set it to 0.6, and we'll keep the same alpha value. So now when I run my game, I'm not going to have a completely black scanline, but I have a white scanline, and we can change these color values to whatever we want. So hopefully you found this interesting. We covered 4 different ways to do scanlines and CRT shaders, and I'll see you in the next video. Thank you everyone for watching the video, and a special shout out to the following users in no particular order: Edward, Victor, Ian, Angel, Ashby, Paul, Darthwolf, Robert, and Annie. Please don't forget to leave a like and click that subscribe button. All the links for this video can be found in the description below, and thanks again for watching.